지금 시간은 2026년 2월 2일 11시 23시 17분입니다. Joining logical application on Azure database for PostgreSQL flexible server. Native logical application is a built-in feature which was introduced in PostgreSQL 10. It is aimed to replicate data between tables into separate Postgres databases using a replication identity using a primary key. It follows a publisher and subscriber model where there can be one or more publishers or subscribers. The publisher and subscriber database can be on the same Azure database for Postgres flexible server or on two different servers. The typical use case for logical applications are setting incremental changes in a single database or a subset of databases to subscribers as they occur. Setting the change to subscribers could also help in event-driven architectures, where the subscriber can process and publish the change to, for example, message brokers like Kafka, etc. Consolidating multiple databases into one data source for analytical purposes. Replicating data between different major versions of PostgreSQL. Replicating between PostgreSQL instances on different platforms, for example, Windows to Linux. Replicating data between servers hosted in different clouds or between on-prem and cloud. A typical flow involves copying the initial data snapshot from the publisher database to subscriber database, and once the data snapshot copy is completed, any incremental changes on the publisher database are sent to the subscriber databases in near real time. Using use case scenario, this blog will share tuning techniques that can be used to improve the performance or the initial data snapshot copy from the publisher to the subscribe database. The blog is further divided into the following sections: server parameters, use case scenario, best practice, server parameters. The parameters that are used to configure and tune logical replication are as follows. Wall level. Fetch the level of information written to the write-away log to logical. Max worker processes. Set the maximum number of background processes that the system can support. The default value is 8. You can set this value to a number which is greater than the number of subscribers and reserve some for table data synchronization and parallel apply worker. Max logical replication workers specifies maximum number of workers to replicate data between publisher and subscriber. It includes reader apply worker, plural apply workers, and table synchronization workers. The default value is 4. Logical application workers are taken from the pool defined by max worker processes. Max replication slows. The default is 10. You can set the parameter depending on the number of publishers and subscribers. It can be influenced by values set to parameter maxing worker per subscription. Maxing workers per subscription. Control the amount of parallelism and of the initial data copy during the subscription initialization or when new tables are added. Currently, there can be only one synchronization worker per table. The workers are dependent on max logical replication worker. The default value is 2. The recommended value is generally about 15% to 75% of the number of records on the subscriber server. For example, if the subscriber server is an instance of Azure database for PostgreSQL flexible server running on a memory-optimized tier, and with an SKU of 16 records, then the value of the parameter can be set to 8. This includes 8 tables can be copied plurally during initial data copy. To make these changes, you need to set max replication slots, max worker processes, and max logical replication workers parameters also. A good value for max worker processes could be 16, one worker per one core of CPU. Max replication slot could be 16, 8 for table data synchronization, additional slots for other purposes, and max logical replication work could be 12 for table data synchronization, plural apply workers for in-flight transactions. We recommend 15 to 75% of total record because if the number of workers doing initial copy is equal to number of records, then you could see 100% CPU utilization on the subscriber server. 15 to 75 is just a general recommendation. You can set a higher value, but making it too aggressive might result in 100% CPU utilization during initial data copy processes on subscriber servers. Max while senders. The maximum number of simultaneously running WAL while sender processes default is 10. It is recommended to set a value equal to or greater than the number of logical replication slots. 되게 use case scenario. In the use case scenario, the publisher database has 6 plus tables on PostgreSQL version 16, and the goal is to complete the initial snapshot as fast as possible. The publisher server is 16-bit core general purpose Azure database for PostgreSQL flexible server with 1 TB storage. And the subscriber server is also a 16-bit core general purpose Azure database for Postgre flexible server with 1 TB storage. Setup on publisher server. Server parameters, while level, logical. Max replication slot is 12. Execute the following statement on the publisher databases. Create a publication. Set up on a subscriber server. While level, logical. parameter 버리고. Best practice. In general, it is recommended to have publisher database and subscriber database on 2 different servers. Follow the server parameter guidelines described above. During the initial data copy phase, you can turn off auto vacuum, increase max bar size to 64 gigabyte if you have storage size of 1 terabyte or greater than that. General recommendation for large storage sizes, and have checkpoint time parameter set to 1 hour. We would like to checkpoint to happen less frequently as checkpoint processes consume additional server resources for that purpose. 1 hour is recommended. There is again general recommendation value. General recommendation value can be less than 1 hour. It depends on data volume being moved, and you can also take into consideration time to recover in case there is a crash during initial data copy phase before coming up with a value. Once the initial copy is completed, It is recommended to vacuum energize the tables and then turn back auto vacuum to on. The checkpoint time and maxwell size parameters should also be changed back to previous values. Vacuum DB utility can be used to manually vacuum analyze tables. For more information, follow the document vacuum DB.